we're talking about Git. It's a version control system, and if you already know what a version control system is, most of you do, then there are still things you need to learn, and they are slightly more advanced things. And you can go to this URL later. There is a video series there. I recorded that video series for you. And I go in IntelliJ, I go through everything you need to do for your group projects and when you are working with Git in general. So I go through the details like click here and run this command and do this and do that. But that's not the purpose of this part of the lecture, this other half of the lecture here. I want to show you the underlying engine, how things work and how Git thinks about your project. So it goes beyond just clicking on stuff and really going deep and understanding what's going on. So let's do that today. And before we even get started, I say this in the video series, I want to say it again because many people get confused. Even people that know Git, they think that it's the same thing as GitHub because, well, GitHub has Git in it, so no, it's not the same thing. It's like email and Gmail. It has the name in it, but you can do email using Outlook or whatever, iCloud. The same way you can use Git without GitHub because Git is a tool and GitHub is just this service from Microsoft that lets you host your Git repositories and collaborate with other people using Git. But it's really just one service. There are others and you can use Git without GitHub. So if you said, like, on the first question, you need to understand what version control even is. And maybe you have worked like this before. You start with a file, and then you change something about it, so you create a copy, and then you change something about it, and you create another copy, and your collaborator sends a copy, and you're managing all these different copies, and you send some by email. Yeah, well, that's sort of a version control system, a very bad one, but it's a version control system. Or maybe you have used something else like iWorks, the iWorks suite, so Pages and Numbers on macOS, or Google Docs. That is also a version control system. There is a version control system embedded in that system there, in that program. And you can see the different provisions over time, and you can see who changed what and so on. That is also a version control system, and it's a better one. Git is like that. It's a version control system, but for your whole project. So if you have a software project, then you're not only versioning one file like you would do in Numbers or Pages, but you're versioning a whole project. And by doing that, you create this timeline, which changes over time. And you can say things like, John added a shopping cart. And then when looking on this timeline later, you can tell who did what, when, and why. And that is more or less what you see in those software that I was talking about, iWorks and Google Docs and so on. And that's automatic. You don't even need to say that you are creating another one of these little boxes on the timeline. Well, when using Git, you have to do that manually, but you also get more control over what's going on. Okay, so let's get started. The first thing about Git is something that you already have, even if you're not using Git. And that is your working directory, the files that you want to keep track of. So your software project documentation and so on. Maybe even binaries like images and videos, but really Git is not the best tool for that. You should use the tool that comes with the software you're using to edit the image or video if you want to do that. But then when you change something in your project, you may have added a line as in the first file, or removed a line as in the second file, or changed the line as in the third file, or even removed the file altogether. Well, Git keeps track of those changes on a line-by-line basis. So you can see that here the diff, or the change set, is not talking about files, but talking about lines and what happened to those lines. So even if you have deleted the whole file, Git keeps track of the fact that you have deleted all the lines in the file. And this becomes relevant when for instance, you are moving files, because Git can know that you are changing the name of the file or moving a file because it sees the same contents in the source and the target. Now, what you can do with these changes is you can first put them in the index, and that is you select those changes to go into the next little box, the next point in the timeline. And you might decide to not include all the changes because some of them you're still experimenting with, but some of them you want to commit to the project, so you add those to the index or staging area, two names for the same thing. And you can see that I selected the two first changes, but not the later two. And then you create a commit. And you can see how exactly to do that in the videos online. But the idea is that this commit contains the changes and also some documentation that goes along with the changes. So in this case, I'm describing what the change is by saying that it's adding a shopping cart, and I am John. Not really, I'm Leandro, but anyway, the author of that commit is John. So this is the first thing I want to have you remember, and that is that Git operates on the line level, not on the level of files. Point next. So you have this timeline, and each node in this timeline, each box, is a commit. And commits are immutable. So if you have changed a file, committed, and then you want to take it back, you have to create a new point in the timeline that reverts the change. But you cannot go into the timeline and change the commit that is already there. Also, commits point to their parents, and that is because they are immutable. So when you're creating a new commit, the parent is already available, so it can point to the parent. But the other way around doesn't work, because when the child is created, you cannot go back to the parent and patch it so that it knows about the child. So in the timeline that you see in Git, commits are pointing to the past, to their parents. And Git stores all this information in this directory called .git. It creates this directory for you in your project. And that directory is called the repository. And that keeps track of your project history. Next thing to note is that the repository is append only. So commits are immutable, and you can only create new commits. You can never remove commits that are already there. This is only half true, by the way. You'll see why in a bit. So, if there is this timeline, how do you keep track of where you are? Well, there is this reference called head. And head is just a pointer to this timeline, and head is keeping track of the version of the project reflected by the working directory at any given point. So when you create a new commit, head is updated for you automatically. Git does that for you. And you can change head. You can go back in time if you want. So let's see here. We have this working directory with 3 files, and we can move in the timeline, going back and forth in time, through an operation called checkout. And when checking out, you can see that 2 things are going to change. First, the pointer head is going to go back in time. And second, the working directory itself will also change. Because back at that point in time, the 3rd file didn't exist. So watch closely. 2 things have changed. So head is a reference pointing at the commit, which represents the current state of the working directory. Now keep that in mind. If you actually try to do this in Git, if you actually try to check out a commit in the past, you enter into this very weird state, detached head state. I was hoping to get some laughs at this one. Thank you. So what this means is that there is this other thing called a branch. And if you don't even know about branches, if you don't even say to Git what branch you are on, then you are on master. And it's this other reference, like head is a reference, master is another reference, and master has this special meaning. It's really just a name, but it has this special meaning that is the canonical version of the project. If you were to deploy my project right now to a server, this is the version you should deploy. And there is this reference, it's always there, and when you commit, Git updates that reference for you. But now, you are in this other commit. So if you want to go back, you can always go back because there is this reference called master. So you can always say, I want to check out master. Let me go back to master. But let's see what happens if you, before checking out master again, you commit. Now, I said it before, Git is updating head as you commit, right? So you create a new commit, head is updated, and now you decide that it's a good idea to check out master. So head moves to master. What happens to that commit over there? There is no way for you to reach that commit following the arrows. That commit is as well as that. So in summary, a branch is a name for a reference, is a named reference. You can give it any name. Master happens to be sort of a special name, but there are other branches with other names. And if you don't have a way to reach a commit following the arrows in the graph, then that commit is lost. That's why you want to keep track of branches, because you want to have references to find every commit in the graph. Now, this is a very important concept. And I see some faces that are like this. So I want to pause for questions, if you have any. Okay. Let's move forward then. Okay, let's go deeper into branching. So I said that there is this branch, master, and now I am not showing you head. So I'm only showing you this branch master. And you can create as many references with names as you want. So currently there is master, but now I'm going to work on this other feature, shopping cart. So I create another branch, and they are all just references to a commit, so they're just pointers. And maybe someone else is working on this unrelated feature of this support chat. They create another branch. And then we go off and we start committing, and we change the code, and we create more commits, and we move forward. Now, if you squint, it starts to look like a tree. That's why these things are called branches. More or less like a tree. And let's say that this other person is working on the support chat feature, and they're done. They are ready to incorporate this change back into the canonical version of the software that should be deployed, back into master. So what they do is they merge master into the support chat branch. And in this case, in this configuration that you see on the screen, all you have to do to merge the two timelines, because the timelines have diverged here, all you have to do to merge the timeline of master and support chat really is just advance the master pointer. And if you just change that pointer and move it forward, then the changes are now visible through the master branch as well. That's called fast forwarding. But now suppose that I have finished my feature, the shopping cart feature. Now in this case, master is not just behind this branch, but it's also on the side. The timelines have diverged. I cannot simply let master point to shopping cart, because that would mean that I would lose the changes from the other branch. So the way it works now is it's also a merge, but it's a different kind of merge. It's not a fast forward. So a couple of things are going to happen now. First, I'm going to create a new commit that has two parents. And second, I update master to point to that commit. So this commit is special. It's called a merge commit, because it's converging the two different timelines. And during this process, you may run into a conflict. You may run into a conflict if there are multiple changes, both in the shopping cart branch and on the support chat branch. There are multiple changes to the same file, to the same lines. So usually Git is very good at solving conflicts for you automatically. So if you have changed different lines on different files, then the merge will just fall through as you would expect. But if you change the same lines on the same files, then Git can't really tell what you want to do there. The changes might even really conflict in the sense that the features don't work well together. I have added a new button that conflicts, that doesn't jive well with the button that already exists for the support chat. So you have to manually go through the changes and see what changes you want to keep and what changes you want to discard. Then this thing doesn't look like a tree any longer, really. It is a directed acyclic graph. That's what a Git repository is. And if you know graphs, you can manipulate the graph arbitrarily. There are Git commands to do anything with this graph. Of course, keeping the constraints that the graph is append only. So let's learn how to manipulate this direct acyclic graph in a few ways. Well, we saw some already. You can move the head anywhere, really, not just going forwards and backwards, but also going to alternative timelines by checking out different branches. Also, if you want, you can, there is this branch that is a label to a commit. You can just take it and make it point, forcefully make it point somewhere else. It's just a pointer, and you can change the pointer arbitrarily. That's called a reset. And another way to change the pointer is to commit, because Git is going to automatically update the pointer for you. But now let's break the constraint. Let's rewrite history. I said that the repository is append only. So you cannot really change the things that are in the repository. There is no way for you to rewrite history, right? Well, wrong. There are ways for you to rewrite history. But you have to watch out for a few things. First is unreachable references. As I showed you before, if a commit cannot be reached following the graph, it is gone. You lost it. So if you are playing with rebasing to rewrite history, it might be a good idea for you to create a temporary branch that points to the old thing that you are rebasing, just so that if things go wrong, you can return to that. Also, it is a good idea for you to check with your collaborators before rewriting history, because if there are other people working on the same branch as you are, and you rewrite history, they might have a version of that old history, and that would be bad. You would need to conciliate them. You would probably the thing you would do is just discard one of the two and keep the other. Okay, rebasing. There are a couple of things you can do with rebasing. The first is you have this timeline, master and shopping cart, before merge. And let's say that there is something in master that is relevant for this feature, for the shopping cart feature, and I want that. Maybe someone made it easier to create new buttons, so I want to use that, let's say. So what I can do is to rebase so that the shopping cart branch is not starting at the commit that it currently is, but it's starting at the top of the timeline, starting at the commit that master is pointing at. And so many things happen. There are these new commits coming off of master. So now shopping cart is coming off of master. I can leverage the features that are in master. Also, there are these commits that were left behind. I said that you cannot really remove or change commits in the repository, but the references are gone, so you cannot reach these commits. they are as good as that. So that's the first thing you can do with rebasing. You can base your branch off of a different commit. Second thing you can do with rebasing is you have the same situation as before. And while working on the shopping cart branch, I was committing often, which I think you all should do. You should commit often. You changed one line and it makes sense on its own, commit it. And you don't even need to write a thoughtful commit message. It can be more of a note to self. Because later, when your branch is ready to be seen by your collaborators and ready to be evaluated by your group advisors and so on, what you can do is rewrite that history so that all those commits that are the shopping cart branch now, they are squashed into just one that has all the changes. And for that one, you write a thoughtful message, you explain what's going on, why you did it, how you fixed the bug, and what is the GitHub issue that you were trying to solve. All these things you can write on the commit message for this big guy. So that is also rebasing. It's called interactive rebasing. So what happens here is that now there is this big commit because it has all the changes from all the other commits. And the other commits, the original ones, are unreachable, they're dead. So that's the second thing you can do with rebasing. You can rewrite history so that it looks good to other people. And of course, you should probably do that when you are done. You are ready to have your changes reviewed and accepted. Okay. One last point about rewriting history is sometimes you commit because you have fat fingers and you typed something wrong and you want to undo that real quick. There's this thing called amending the commit, and you do that by passing a flag or clicking on some checkbox on your Git client. And when you do that, what happens is that that old commit is dead and you just create a new one. So it's a quick fix for some small mistake. Okay, I want to go over a few edge cases. So if you have a commit that is dead, somehow you were rebasing or something, and you lost a reference to a commit, there is a way out. It's called a half-log, and check it out if you are running into problems. Also, you may run into this other problem called a dirty index. Hasn't been showering lately. And what it means is that you have changes on your working directory that you have not committed yet, but you're trying to do some operation that changes the working directory. For instance, you're checking out a different branch, or you are getting changes from someone else, and that is trying to change your working directory, and that is no good because there are changes in your current working directory as of now. So you're in a dirty index state, and the solution to that is commit your changes. As simple as that, or stash your changes, which is like a lightweight commit you create just for stashing the changes for later, and then you can recover them later if necessary. And one more thing I want you to know about is, suppose you want to know what changed in a file, and you want to know who did this line, who changed this line because it introduced a bug or something, and you want to trace back the author of that line and maybe the commit that introduced the line, trying to see if there is some justification for it. There is this command called blame, a very good name for the command, so you can see what lines changed in each commit. To wrap up, Git is distributed. What this means is that you have this repository in your computer, and you want to talk to a remote. You want to change not only the current state of your project, you could do that by email, for instance, but you want to change, you want to send the whole history of the project. So you might want to send that to a colleague's machine, or to GitHub, or to some other hosts like GitLab and Bitbucket, or you want to send it to Heroku so it will deploy your application. Travis CI, our continuous integration server for this semester, will also get your project this way. you can send the whole history of the project in an operation called push. Notice that there is an exact copy over there. Also, in your machine, because you have pushed, there is now this other branch called origin/master. Origin is the name I'm giving to my remote here. It's usually the name you give to the remote that is the canonical version of a project again. So origin/master is probably the source for the project. So you push the whole history of the project, and you get that reference that represents the state in the remote from your perspective. Next, suppose someone else has pushed this cart branch to the remote, maybe to GitHub, let's say, and you want those changes. What you can do is to fetch. And now I have this reference origin/cart. Cart is the name of the branch on GitHub. So I have this reference on my local machine, and I can even check out that reference, and it will create a new cart branch for me that represents my view of the branch on my machine. And you might have heard of a different name for this operation. Instead of fetch, you might have heard the name pull. And a pull is just a fetch followed by a merge. So it means that not only you are getting that change, but you are also creating that cart branch for yourself. And as I said, Git is distributed, which means that any machine that has the project can talk to any other machine on the network. There might be even multiple remotes. As you can see on the machine in the middle, there are multiple remotes for the same machine. It's capable of pushing and pulling to different places. Our happy path for this semester is to have GitHub as the canonical version of your project, the centralized source of truth, and everyone's pushing and pulling to GitHub and from GitHub. So GitHub is our origin for this semester. And that's all I have to say about Git. Now, move on to your group projects. Thank you.